You know, we trust the cloud with pretty much everything, our photos, our documents, our entire digital lives. But have you ever stopped to think about what that trust really means? A service like Amazon S3 doesn't just promise to keep your files safe for a year or even 100 years. They promise to protect them for millions of years. So how on earth is that even possible? Well, that's the incredible feat we're going to break down today. It all boils down to this one kind of ridiculous number, 99.9999999%. In the tech world, they call this 11 nines of durability. I mean, that's a promise so close to absolute perfection that it's actually kind of hard to wrap your head around it. So what does 11 nines actually feel like? Well, think about it like this. If you stored 10,000 of your most important files, your wedding photos, your kids' first steps, everything, you could expect to lose just one of them over the next 10 million years. That's not just data storage, that's practically geological time. And yeah, this brings up the big, obvious question. I mean, we all know technology is fragile. Our laptops crash, our phones break, and the hard drives spinning away in these giant data centers, they're no different. They fail constantly. So how can anyone with a straight face promise that kind of permanence? Okay, so let's start with the first thing that probably pops into your head. If you're worried about losing something important, well, you just make a bunch of copies, right? This is what you might call the brute force approach to keeping your data safe. The technical term for this is replication, and it's pretty much what it sounds like. It's the most intuitive solution. You take a file, you make several identical copies of it, and you stick them in different places. If one copy gets destroyed, hey, you've still got the others. Simple enough, right? And here's how that plays out. Let's say you upload 1 terabyte of data. The system immediately creates 2 more full, identical copies. So your 1 terabyte now takes up 3 terabytes of actual storage. Your file is definitely safer. Yeah, but this whole approach creates a huge new problem. And that problem, it's all about money. While making a few copies works for you and me, for a service like Amazon, it's a complete financial disaster. They're not storing terabytes of data. They're storing exabytes. That's 1 billion gigabytes. Having to buy 3 hard drives for every 1 hard drive's worth of customer data would make cloud storage so expensive, none of us could afford it. Just look at this chart. It really lays the problem bare. For every single unit of data you want to store, the company has to buy and maintain 3 units of physical storage. That's a 200% overhead cost. It's just not sustainable. There had to be a smarter, more elegant way to do this. So, if the brute force method of just making tons of copies is off the table, what's the alternative? Well, the real solution is far more elegant, and believe it or not, it comes from a pretty unexpected place. See, the secret isn't about storing more data. It's about using some really clever mathematics to protect the data you already have. This is where we shift from brute force to, well, brain force. And this brilliant solution is called erasure coding. The core idea is to stop making copies and start doing math. You take a file, you break it into smaller pieces, and then you use an algorithm to generate a few new pieces. These are called parity fragments, and they are the absolute key to this whole system. And get this isn't some brand new idea. This technology's roots go way back, solving some really tough problems. It was used to make sure a signal from a space probe millions of miles away could be pieced back together, even if parts of it were lost to static. It's even the same basic principle that let your old CDs play music perfectly, even with a bunch of scratches on them. So the big mental shift here is from copying to calculating. Instead of just duplicating the data, we're going to strategically split it and then add just enough mathematical information to make it almost indestructible. Let's see how it works. All right, let's imagine this is your file. But it's not really one solid thing, right? It's actually a collection of data blocks. For our little example here, let's just say it's made up of 4 blocks. We'll call A, B, C, and D. Okay, step 1 of erasure coding is super simple. We just split the file into what are called data shards. So we literally just pull our 4 blocks apart. Now each one is its own little independent piece. All right, now this is where the magic happens. We take those original data shards, A, B, C, and D, and we run them through a special algorithm. This creates 2 brand new shards, which we'll call P1 and P2. Now, it is vital to understand that these are not copies. Think of them more like a mathematical summary or a checksum that holds just enough information about the originals to be able to rebuild them if we need to. Then you take all 6 of these shards, the 4 originals and the 2 new parity ones, and you spread them all out across 6 completely different physical servers in a data center. Each piece is now totally independent of the others. Okay, so everything is stored safely. Now let's introduce a little chaos. Let's say disaster strikes. Boom! Server 3 and Server 4 both fail completely. Maybe their hard drives just died, maybe the power went out. Whatever the reason, shards C and D are gone. Poof! Vanished. Now, this is the moment of truth. In the old copy and paste system, this would be a catastrophe. But with erasure coding, it's just a math problem. The system simply gathers up the surviving shards, A, B, and those 2 parity shards, P1 and P2. And because those parity shards hold the mathematical relationship between all the original pieces, the algorithm can perfectly reverse engineer and rebuild the missing C and D from scratch. Think about what just happened there. We lost a third of our hardware, but absolutely 0% of our data. How cool is that? Now, this mathematical wizardry isn't just a cool party trick. It has a massive, real-world financial impact. This is the very thing that makes the entire modern cloud we use every day economically possible. So let's just put them head to head. Replication stores 3 full copies of your data. It's simple, but it's really expensive. Erasure coding, in our examples, stores your 1 original copy, just split into pieces, plus the equivalent of about half a copy's worth of that parity data. It's just so much more efficient. And this chart really quantifies that payoff. Replication's 200% overhead is just crazy. By using math instead of brute force, erasure coding delivers that same incredible 11 nines guarantee of durability, but with just a 50% overhead. You get the same unbelievable protection for a fraction of the physical cost. And that is the ultimate takeaway here. This clever bit of math is the silent engine running behind the scenes of our digital lives. It's the reason you and I can afford to store our photos, back up our computers, and stream movies. This efficiency is what made massive scale data storage possible for everyone. So we'll end on this thought. We've just seen how an elegant mathematical solution turned a financially impossible problem into the foundation of our digital world. It really makes you wonder, what other impossible problems out there are just waiting for the right algorithm, the right bit of clever math to come along and solve them?